Welcome back. This is the final lesson for Unit 2, Data Transmission, and in this particular one, we're going to be looking at the need for and purpose of encryption when transmitting data. You should also understand how data is encrypted using both symmetric and asymmetric encryption. Let's start with security risks. As data is shared across the internet, there are inherent security risks as well. Data can be corrupted or deleted either through accidental damage or through a malicious act. Data is threatened by malicious software, hackers, or accidental damage all the time. Whether a user is working on an offline computer or a computer connected to the internet, keeping data safe is very important. So it falls on us to ensure that when we are transmitting data, we can keep it as secure as possible. And one of the ways we can keep it secure is by using encryption. Now, encryption doesn't mean that people won't be able to steal our data. Encryption means that if they do steal our data, it won't make any sense to them. Now, before we begin looking at encryption, there are a few key terms you need to be aware of. Now, these key terms are really important because they can come up as 1 or 2 mark answers or sometimes match the word to the description type questions. So we start with encryption. Encryption is the process of encoding data, so it cannot be decoded without a key. The next one is plain text, and this is the name given to data before encryption. Ciphertext is a name given to data after it is encrypted. Encryption key is basically an algorithm that is used to code or decode data. Whether we encrypt or decrypt, that happens through the use of an encryption key. Public key is an encryption key that is shared by the sender with everyone, and this is normally used to encrypt or encode data. Private key is an encryption key that is only used by the sender and it's not shared with anybody else, and it's used by the sender to decrypt or decode data. Symmetric encryption is when we use the same key for encrypting and decrypting data, and asymmetric encryption is when we use two keys, a public key to encrypt data and a private key to decrypt data. Now, these key terms are of vital importance, so do pause the video and make sure you jot these down. Okay, let's look at encryption now. You can have the best security in the world, but your data can still be intercepted. Encryption protects your data by converting it to an unreadable format. Only the one who has the key or the encryption key can decrypt it. Now, we have been encrypting messages for a very long time in our history. During Roman times, Caesar's name inspired the Caesar cipher, where he used a similar technique with a shift of 3. The shift can be plus or minus 3. Now, if you look at the little key at the bottom, plain text A becomes X, B becomes Y, C becomes Z, D becomes A, and so on. Now, if I wanted to spell bad, I would simply use Y, X, and A. I will transmit this data and the interceptor will simply get YXA, not the original message, because they might not have the key. Now, if you want to try this out yourself, you can try encoding your own name using the on-screen key and see what you get. However, there's problems with this type of key. This cipher has 25 possible offsets or keys which can easily be cracked. So you can try +1, +2, +3, or -1, -2, -3, all the way up to -25 or +25, and you can easily crack the code. Modern algorithms are much more complex. The longer the key is, the harder it is to crack. Now, if you look at the amount of bits we use for a key, if we have 1 bit, there's 2 possible combination, 2 bits, 4 possible combination, 8 bits, 256 possible combination. So if we go to 128 bits, we get 300 times 10 to the power of 33 possible combinations, and that can be difficult for supercomputers to crack via brute force method. Okay, so let's look at the different types of encryption out there. There's symmetric encryption, which requires the same key for encryption and decryption like the Caesar cipher. Both sender and receiver use the same key, which can lead to a security risk. If someone intercepts the key, they can easily decrypt the messages that are being transmitted. Asymmetric encryption, on the other hand, requires two keys that work as a pair. Both these keys are mathematically linked. The first key, called a public key, is used to encrypt the message. This can be distributed to everyone. The second key, which is called a private key, is used to decrypt the message, and this is kept secret. Similarly, a message encrypted with the second key can only be decrypted with the first key. This is much more secure, but quite complex to implement, which is the drawback of asymmetric encryption. Now, you should also be aware of the differences between public and private keys. The first key, which is sent to anyone who wants to send us an encrypted message, is called the public key. This is the one that we distribute to everyone. We don't keep this one secret. The second key is kept secret and known as the private key. We don't give this out to anyone. As long as this key is safe, the encryption is very difficult to break. When a user logs on to, say, a bank's website, the bank's public encryption key is downloaded, and that's used to encrypt any communication with the bank. Any message sent by the bank is encrypted using the bank's private key, but it can be decrypted using the public key on the user end. Digital certificates, digital signatures, and encryption protocols like secure socket layer and transport layer security, SSL and TLS, all use asymmetric keys. So public key isn't kept private, it's distributed to anyone. It's normally used for encryption, and private key is kept safe, it's not distributed to everyone, and it's normally used for decryption. And that's all for this particular lesson. And with this lesson, we finish Unit 2, Data Transmission. You should be able to answer the following questions. You should be able to explain the difference between plain text and ciphertext. You should be able to describe symmetric encryption. You should also be able to explain what is the problem with symmetric encryption. You should be able to describe asymmetric encryption and explain the role of public and private keys in the encryption process. That's all for now. If you do have any questions, please get back to me. Otherwise, I'll see you in the next one.